Hello guys, welcome back to my channel. Today we are going to talk about logic gates. Now logic gates are the basic building blocks of digital circuits. It is an electronic circuit with one or more inputs and only one output. Now the relationship between the input and output is based on a certain logic, and hence the name logic gates. In this we have NOT gate, AND gate, NAND gate, OR gate, XOR gate, XNOR gate, etc. Right? So we're going to specifically talk about one gate, and that gate is NOT gate. First of all, I want you to understand basically what is digital. Digital means zeros and ones. Zero means it's off or low. One means it's high. Okay, means there's an input. Now in all the devices that you have, they all have these logics inside. Okay, so we're going to do some project to demonstrate this, and for this I've gathered a few things that I need to do this, like the breadboard. I have some transistor here. This is an NPN transistor with I don't know whether you can see this. There are just 3 pins. This is emitter, base, collector, and if we flip it this way, then this will be the collector, the base, emitter. They're so tiny, I don't know whether you can see this. If it's, oh sorry, or let's just put it this way. It's a small guy here, this. And then we have the switch that we're gonna use. Okay, here you press it on, you press it off, on, off. It has 3 pins on either side. Then you have an LED, light emitting diode. One leg is longer than the other. The shorter is negative, the longer one is positive. Let me flip it like this so that you can see it clearly. See, this is positive, this is negative. And then I have a couple of jumper wires. These are called jumper wires, which you use to connect the circuit. And then I have this is a 9-volt battery, a 9 volts battery. So this is a negative side and this is a positive side. I hope you know what is volts. Then we have resistors, 220 ohms resistors, and I don't know whether I can be able to lift this up. Actually, I've constructed this. We have the breadboard, which we are using to connect the circuit because we are not going to do soldering, so we use the breadboard for the project. So what this circuit does, I'm going to show you. Sorry, before that, I'm getting ahead. We have some symbols to illustrate some of these things. And this, you can see, that is a symbol of the NOT gate. This is a symbol of the NOT gate. This is input, that is output, and this is a symbol. And that is something we call the truth table. Truth table. It's called truth table of a NOT gate. So you can see one. This input here, it looks flipped. Okay, input 0, output 1, input 1, output 0. And down here I've done the maths, like 0 prime is 1 and 1 prime is 0. Boolean algebra, you know what that is. Okay, and I've done some conversion of digits. For example, this represent a 5. That will be another video. You can convert this to decimal. This is binary, and that's in digital circuits we use binary. And then we have a drawing here, sort of to show the circuitry. What is not very clear here. We have the base, this transistor, the base, sorry, this is a VCC, VEE, the base. Circle around like that. The schematic diagram also of the transistor is here. So what this circuit does, it acts as an inverter. It inverts what you put inside. So I've constructed it here because it's quite work to do it practically under camera. I've done the construction here. How can I show it? Yeah, you see, I constructed it there. So there are two parts of the rail, the negative side and the positive side, and I'm going to show you. And 1 minute. Yeah, I've just linked it. Actually, I'm trying to find a way I can make you see this. I don't know. Let me put it this way. Put it this way. Still you cannot see it. I have to lift it up for you. So it's quite crazy here. It's quite crazy because you can't see it from there. I'm trying to link it up, guys. Trying to link it up. Right, I just linked it. Maybe I'll flip a camera a bit so that you can see it. If you can see it, I wonder why it's come out. Sorry, they're quite delicate to deal with. It needs more than 2 hands to do this. I don't know exactly how to do this. I want to explain to you this thing very well, but it's a problem here with the camera. You can't be able to see this properly. I'm trying to move the camera so that you can see camera angle. It's quite difficult to show this on the camera. Just let me try. See what I can be able to show you this practically. I'm trying to connect this, but the wire is so loose. I'm dealing with the breadboard here, my friends. And they're so tiny. Yeah. Come on. I'm trying to enter this in its right place. It needs a cameraman here. No? Yeah, so let me try again, but I can be able to show all it is like this. Yeah, I'm trying to show you this thing like this. Now this is in an in an off state, when there's no current flowing through the transistor base, the LED is on. That means here there's zero input. If you measure the potential here, it will show you zero. When I press this, the transistor goes off. When I'm putting the input from here, now you'll see this, the transistor goes off, because across the transistor the potential difference is low and the LED cannot go on. There's zero differential between the LED. So you see, the LED is on, the LED is off. These are the jumper wires are connected here. This is from the positive rail to the resistor. The resistor is connected to the VCC and the longer leg of the LED, which is connected here. And this is another, from this side I have another same resistor here. So we have resistor here, resistor, we have the jumper wire connected to this part of the resistor from this side, and another one from this side. This is the side of the switch. So when I press like that, you see it's on. That means there's no current going through the base of the transistor. Now this is why the transistor acts as a switch. Okay, so when I press the switch on, when there's current flowing through the base, the LED goes off. Okay, these are all the jumper wires. I've connected the battery from both sides. I won't be able to show you this. It's not good. You can't show this. The red wire is connecting to the positive from the battery, and the black wire is connecting to the ground, the negative. Okay, and the one of the resistor is connected to the positive side, both, but one through the jumper wire and one through the switch. So this is a demonstration of the NOT gate, in the sense that when there is a current through the base, there's no current through the base. This is free. The switch is open, the LED is on, and when you put the current through it, the LED goes off, because of the reason I've explained. Okay. So basically these are NOT gates, and that's how the relationship between an input and output on this gate called NOT gate. And this is whenever there is an input from this side. Show you the diagram. Whenever there is an input from this side, okay, then the LED will go off, because this is a base. So the schematic diagram, see here, this is a base. The LED goes off, and if there's no input, the LED goes on. I have not drawn the complete circuit, but this is how it looks like. So this is a NOT gate. Nice, it's logic circuits, and that's how your mobile phones work, your laptops work, any electronic device works through these things called logic gates. They're very, very fundamental. Without them, we're not going to have all these things, like the memories that are created and stuff like that. So we under one or two more gates, AND gate, a NAND gate maybe. NAND gate is just when you have AND gate. I'm getting ahead. We're going to do AND gate, then we do NAND gate. in the future episodes. Okay guys, thanks for watching. I hope you have learned something. So we started a new series on this, and please stay tuned so that you can learn more about digital circuits and the electronic circuits and how they work and how they are important in our devices, electronic devices that we carry around. Okay, thanks for watching. Please subscribe, share and like, and see you again. Bye.